Welcome at this webinar of the Top Sector Logistics on the application of advanced technologies in spare parts supply chains. My name is Albert Veenstra. I am Scientific Director of TKI Dynalog of the Top Sector Logistics. The Top Sector Logistics is a program in which companies, knowledge institutes and governments work together towards emissionless and competitive logistics for the Netherlands. In the past 6 years, the Top Sector has supported dozens of projects and initiatives in which boundaries were pushed. New scientific insights, practical concepts and solutions, tools for businesses great and small. We are sharing these results through this webinar cycle, where we put the experts in the spotlight. In this webinar, we are going to have a closer look at the digital spare parts supply chain. The practical case that we are discussing with 3 experts today is the culmination of work done in a lot of projects such as sustainable impact of new technologies on after-sales service supply chains, Procelo Next, and many more. The service logistics community, organized in the Service Logistics Forum, has a long history of advanced research combined with very practical and fruitful applications. We are very proud that we have been supporting this through the activities of the Top Sector Logistics, and we hope that you enjoy this webinar. Our 3 speakers represent a typical combination of the application of advanced knowledge and tooling that I was just talking about in a very relevant context. We have here Niels Knopius, Michel Kokkelkoor, and Joris van der Zanden. And let me first introduce Niels Knopius. He works at Twente University, and he has a research background in the field of additive manufacturing, has worked with a lot of companies to strengthen their additive manufacturing initiatives. Niels, I give you the floor.
Yeah. Thank you, Albert. Also for me, welcome. Before we really go into the details also about how you can strengthen your AM initiatives, I would like to do some short bookkeeping and tell you what we are actually talking about, actually which technology it is. In particular, for the digitalization, additive manufacturing is considered quite critical. And what is important to state at the beginning, additive manufacturing is not only one technology, but it actually is like an entire group of production technologies. Down here, you see some different technologies, but those are definitely not all. And what's probably also important to mention is it is often referred to as 3D printing, which is probably the more common term. Today, actually, already quite a wide range in terms of size and material can be produced, and it's ever increasing, both from a technical point of view, but also from an economical point of view, which is maybe at the moment even like the part that is lagging a little bit behind, because as you also see here in the overview, there's already quite a lot of things possible. What are now actually the benefits of additive manufacturing? I'm now trying to be quite broad, but basically you can distinguish this in 2 segments. On the one side, you have like everything that relates to design improvements or novel designs, and on the other side, the improvement of the supply chain. And maybe directly at the beginning, a key takeaway is those should not be mixed up. So what I noticed also when working together with quite a lot of organizations, what is often happening is that additive manufacturing is judged based on whether it is the best production technology. But actually what you should do instead, especially if you have the supply chain in mind, is you should ask the question, is additive manufacturing the best technology for producing these parts, given also the supply chain in this context? So it should not be considered in isolation. Today, we will mainly focus on the supply chain improvements of additive manufacturing. I don't want to now give you a complete overview what is all possible, but things that are often mentioned here is like stock reductions through the shorter lead time of additive manufacturing, or because we can produce parts close to the point. But let's move forward. So who is now actually affected by this entire digital transformation? In general, one could say the entire supply chain is but there are certainly some key players that like really should take this into account. There are first the OEMs that usually have the intellectual property rights, so they are really a key player in this entire transformation. Then we have the logistic service providers, for which it is of course quite an important aspect if now suddenly the production is not around the globe anymore, but it's more local, so they have to reconsider the business models. For example, you see nowadays already that UPS is building up their super printing centers in order to also be part of this entire initiative. Also for integrators, the sourcing will change significantly, whereas now like components of their parts are sourced quite global. This might become more local. So they really have to reconsider their sourcing modes. And most importantly, and that will be also the main focus of today, are the users, obviously. For them, through the digital transformation, the entire service model will change. Suddenly, you don't have to order a spare part anymore with half a year of lead time. Suddenly, you don't need huge stocks anymore in order to achieve a certain availability level. So, like for the users, this entire digital transformation holds a huge opportunity that I hope we will dive a little bit more to today. Now the next segment will be actually quite a mouthful, and it's probably not like the common way of presenting, but I think it's nevertheless really important to give you an entire overview how you as an organization can structure your AM initiative and what are the different phases. So be prepared for a lot of information now coming. So in the first phase, like you are now like a organization that hasn't done so much with additive manufacturing yet. What do you actually want to do at the beginning? In the first phase, it's really important, and I only can stress this more and more, to build internal support and also to make people understand what is this actually about. And for that purpose, like one of the key actions here is that you establish first a cross-functional project team, and the emphasis is here on cross-functional. What I see is done not so optimal is often that there are only technical people in lead for digitalization initiatives, whereas it should be actually all parts of the organization that are involved. So people from procurement, people from supply chain, technical people, they should come together and there should be a joint project team. Also, in order to like engage the entire organization, what I often saw as a really good step is to install basic additive manufacturing equipment. I mean, there are like quite simple printers that you get under 1,000 euros. Why not just putting them on your work floor, letting people try this out? Also offer like fundamental workshops with your employees. Everyone that is interested in those type of workshops, you will also discover who actually has organic interest in this technology and who might be also in the future one of the key personnel that you want to rely on. In that context, what often helps and what I also often saw are like small case competitions. Let people come up with their cases where they think, yeah, well, actually, maybe here it might make sense to use additive manufacturing. And then the output of the first phase should be a strategy plan. So what do you want to achieve actually when with this initiatives? What are the milestones? And that should be, of course, then also backed by the upper management. In the second phase, then it has to become a little bit more company specific, let's say. So you as an organization really have to understand where are the benefits of additive manufacturing for you. What is there a good approach is probably that you have at first a holistic perspective on your entire spare parts, and then you categorize them. So you will see, okay, you have like certain spare parts where intellectual property rights are more important. You have spare parts that are more critical. So like really think about it more from a holistic point of view and try to cluster your spare parts assortment. Then also, in order to get a little bit a better understanding of those clusters, select for each cluster a representative pilot study, where you just like simulate now the entire transformation. What do you have to do? So you identified now this part. What is the next step? Probably you first have to figure out, is it actually printable, for example? Then who is owning the part right now? Whom you have to contact in order to get this working? What type of certification or qualification is required? So those questions should be like understood, not addressed yet, but you should understand for each cluster what it is about, so that you then in the end really have like the benefits and challenges per cluster and understand which stakeholders involved there. And at the end of phase 2 now, you have a good overview. What are the clusters that offer you a lot of benefits and maybe are not so complex? So maybe you want then to first focus on those clusters in order to bring your initiative forward. In phase 3 then, it now really goes one step further again, so that you now really, for your focus clusters, execute those pilots. Like, it's really learning by doing. So it doesn't help to only theoretically talk about it. You really want to then also bring some parts forward and exercise this transition, as I elaborated there. And what you will notice there, you will like get some roadblocks. And don't get stuck in those roadblocks, but try to like move to a different cluster if it takes too long. But if it is an easy roadblock, great, then you have it solved. Also, what is usually a very good approach here is to do scenario analysis. So, for example, if you use sort of insights of, okay, let's assume for this cluster I am able to, in a worst case scenario, print 5% of the parts. In a best case scenario, let's say 20%. On average, with additive manufacturing, let's say we are able to reduce the lead time by 30%. And with those type of scenarios, you now really can calculate what the actual benefits are for this cluster and get a very good understanding. And also you will understand by exercising those pilot studies, what type of internal and also external resources do I need? What do I want to do actually internal, and what do I want to outsource to third parties? In the fourth phase then, you want to scale up. So it's now you understand what are the big bang clusters, let's say, and now you want to really digitalize this entire cluster. What really helps there is a systematic screening of the parts that you are considering, which we will also talk a little bit more about in later segments in this seminar. Furthermore, you want to have like really your ecosystem set up. With which suppliers do you want to work together? With which AM factories do you want to work together? Which OEMs are very relevant for you in terms of IP? And then when you have this all done, you will see that suddenly things start to really exponentially increase the number of parts that you have. And if then, let's say the train is running, you are coming to the fifth phase, and that's a very important phase actually, because in there it's all about knowledge management. You really have to systematically store all the information that you gain during your AM initiative and concerning each specific part. You have to understand why a part is printable or not printable, and this has to be documented so that it's easily accessible in case something is changing. Also, what is very a good thing there is actually to build an entire track and trace system. So to really see which AM parts are used right now to gain information. What are the failure behaviors of this part in comparison to other parts? So that you then also can, for example, continuously improve the design, which is now possible with the technology as additive manufacturing, where the setup costs are not so high anymore. So that's the last phase. And before we now hand over to the next segment in the webinar, I want to prepare you a little bit, because you will see the next segment will talk a lot about it, namely about the question how to identify high impact parts. So what you see here on the left picture is basically what I talked about. You have your entire spare part assortment, have different clusters that have different benefits and challenges. In the middle screen, you found out that each cluster has certain characteristics based on all your studies. But now you have like tens of thousands of spare parts in this cluster. What are you doing now? I mean, like we cannot base this anymore on a belly feeling. I mean, it's like the risk is way too high that you lose low hanging fruits. Also, you cannot assess the entire assortment because it takes time and it is expensive to assess every part. So you have to prioritize in some way. And a very good approach here is then a scoring and filtering approach that can help you there. How does now such a scoring and filtering approach work in a nutshell? So at first, you consider all your parts that are relevant for those clusters that you want to consider. And then you will see that in your ERP system, PLM systems, and all your data warehouses, let's say, there are certain data available. Are they consistent or are they quite different per part population? So there you want to define which population you want to consider jointly. Next, then you have like the scoring and filtering procedure that is built then on, I call it spare part attributes. So you have like the demand rate. And since you have like, for example, and since you have insights as additive manufacturing is very helpful for low volume parts, that might be a good indicator. Similarly, you have things like this lead time that it requires currently to get a part. Like a long lead time might be very indicative that additive manufacturing might give you a good result here. And on the other side, what you also should take into account, what are your goals with your initiative? Do you want to reduce cost? Do you want to increase your supply chain resiliency? So this should be all part of the scoring and filtering procedure that then ultimately leads to this ranking that then prioritize the approach, which spare parts you want to assess first. And now in this next segment, you will then also see a commercial solution for this approach.
Niels, thank you very much. We have some possibilities to ask questions. The way you do this is by typing your question into the chat box in this webinar environment. There is a question about this framework. I think it makes a lot of sense to look really good at spare part volumes and the population. But what if your data is poor? What happens then?
Yeah, if your data is poor, I mean, like to be honest, I did this approach now already with several organizations, and indeed there are differences across organizations, and it is of course nice if like your data are all in great quality, but there will be always some data that you can use, and already like this little bit might help you to like avoid, let's say, 20 technical assessments of a spare part, which could amount to several hours of engineering time. So like no matter like what data quality you have, like this type of filtering and scoring approach will definitely give you benefit. And to be honest, I think every organization that deals with a large spare part assortment will also have some insights in order to, for example, set their stocking levels. And those type of data are really relevant for this analysis. So I think this will always work, and that's also my experience no matter which service organization I was working with.
Okay, thank you very much. I think that sounds hopeful. Okay, we will continue with the next speaker. Niels already announced it. We are going to listen to Michel Kokkelkoren of Dymanex, who is offering a commercial application to actually support this process that Niels has just sketched. Michel has an engineering and supply chain background, among others from the automotive industry, where he has worked in practice with integrating additive manufacturing in the supply chain. And he is currently responsible for business development, customer projects, and the development of supply chain inspector analytics at the Dymanex.
Yeah, wonderful.
Yes, go ahead.
Okay, excellent job, Niels, and thank you, Albert. Also from my side, welcome to this webinar. And as Niels already mentioned earlier, is that it's identifying the potential within your supply chain can be very cumbersome and also very challenging when it comes to gathering all the information from a supply chain point of view, but also from a technical point of view, where you would need to go through thousands and thousands of drawings finding the technical potential for additive manufacturing. And that's one learning that we have seen with our customers during the past years. And based on that learning, we basically developed Supply Chain Inspector. And Supply Chain Inspector allows you to, with a limited amount of data available from a supply chain point of view, but also from a technical point of view, still provide you with a good insight on the potential for additive manufacturing and building a strong business case showing that actual potential for additive manufacturing. In order to do so, we have drafted a small video showing you the ins and outs of Supply Chain Inspector.
Hi, my name is Michel, and I would like to introduce to you the Supply Chain Inspector, our tool providing you with insights in the potential of additive manufacturing for your supply chain. We will have a further look at how easy it is with this tool to identify all the parts eligible for additive manufacturing, not only based on supply chain data, but also from a technical point of view, where we do an intake on those parts and provide you with actionable insights on the run, basically. Before we do that, I will quickly take you through what Diamondx has to offer. It's not only the data import and providing you with actionable insights. We will offer the full program, basically. That starts, as I just mentioned, with the data import and the data aggregation. And you know how cumbersome that sometimes can be when you have to extract Excel files, merge those, and make them available for further analysis. That's something that we will look into with Supply Chain Inspector, how easy that is. And in one way also the actionable insights that you can take out of it. Once we have done that, we continue with the design conversion. So the parts that have been identified as eligible for additive manufacturing will have a technical intake. We will look at the post-processing. When that is all done, we can order that part and make it available via smart routing and applying the manufacturing quality control as we have it in place, and deliver that part to your door in the most convenient way. As I mentioned earlier, for now we will start with the data import and actionable insights, and that's basically what Supply Chain Inspector is all about. Taking you to the introduction screen of the Supply Chain Inspector, and I will focus on the available screens in more detail. If we start with showing a high-level overview of the potential parts, once the data has been uploaded, then we see in green the parts which have immediate potential. So those are the parts where you can start working on immediately as from day one. So the same day that you uploaded the information, you have already a high potential available on your desk. Then we see the parts in orange. This is the longer term potential. So those will be the parts that once we have more data available will move into the green area. And the parts in blue are either the parts that are for now out of scope because of weight and dimensions, but as soon as the technology evolves, those parts will shift into the orange and also into the green section. Fun part here is that this is live. This is not a one exercise that you do. As soon as we can provide more information like supply chain data, this all shifts, and you will see that the potential will grow increasingly. This was high over. Taking you into more detail is in this pie chart, where you can see in green, same as we saw in the funnel already before, is that the high potential. And you must see that if you have a data set of 500,000 or maybe even 1 million data records, it's quite difficult to find the potential itself, but also once the potential is available, to prioritize that, since it's very difficult for the engineers within your company to pull out 5,000 drawings and start analyzing those. So if you can prioritize everything that's required, then it's more convenient and it's also manageable. Going through the orange section, there are two topics there. That's the future supply chain potential. That's basically the parts that will be available for additive manufacturing now already, but from a supply chain point of view, those parts are not really interesting at the moment, but they will shift to the green section very, very soon. The second part of the supply chain inspector is making it easy for you to see which data properties are missing and which data properties are to be completed in order to increase the potential for additive manufacturing and make those parts also available and moving them into the orange or into the green section. How to do that, how to move those parts from blue into the orange and the green section, that's something that we do in the next view, and that's basically showing you which data properties are missing, and that's done in the parts catalog data health checker, as we name it. And as you can see now, the entire analysis is based on very common, almost standard data properties that is used in the everyday supply chain. So we see like MOQ, we see a stock on hand, a purchase price, which is of course very obvious. Missing the weight and dimensions, that's one of the index criteria that we use. And historical sales is one of the analysis that we apply as well. Also pretty common information. And what makes it fun is that supply chain inspector itself takes the service lifetime of a component into the calculation, which makes that even that is taken into consideration. Collecting the data, as you all know it, and I mentioned it earlier, is that as soon as you have a download from your ERP system and try to merge that into an Excel sheet, 9 out of 10 it will crash immediately, being there myself, and I know the struggle. And if you have to do that monthly or even quarterly, it's very cumbersome to get that information together, and doing an analysis on that is very difficult. So what we have offered, or what we basically offer now, is an easy insight on which data properties are missing. In this case, it's the missing purchase price. With a simple click on a button, you can see which parts are missing. And also we have an export functionality showing you the potential in an Excel sheet, provide that to your data analyst, and then have it uploaded very, very easily in our drag and drop option on the platform. So actually it is getting the download, providing the data properties that are missing, upload them, and there are no more crashing Excel sheets as you have struggled with before. So that is done. So we have an easy upload, we have immediate potential. Once the information is available and we have our high-level overview on what's available, you could still end up with tens of thousands of parts which are eligible for additive manufacturing. And since we all know that it's not possible to retrieve all the technical information for those items, we can do a fine-tune on the potential that's available. And we can do that by providing you with a subset of filters which you can apply, making the potential suitable for the direction that your company is focusing on. So it's either shortening the lead times or lowering the MOQs and applying that. So you can basically customize the view of the parts you would like to focus on first. The list of filters is extensive. It's custom built, as I said, so you can tailor it to the way you would like to see it. As you can see, the GUI itself provides you with all the filter requirements that you need to down drill the information available. The fun part of which I like the most is if you still have a large subset of data available after you already provided us with the drill down and which items are available. We already applied the filters. It still could lead to a large data set you are looking into, and you would still need to gather a lot of drawings. In this case, we have the semantic search functionality, and that's a learning that we do looking into the description of the items. And by seeing which items are eligible, have been eligible in the past, we apply that knowledge over the uploaded data set, and that will make it the likeliness of the parts that are listed in your results increase that. So it provides you with an even higher potential on the parts that are eligible for additive manufacturing. So we started off with uploading the data, providing you with the insights. We did a further down drill on the parts that are eligible based on the supply chain criteria. We already also did the technical analysis, taking weight and dimensions into consideration. And now we even enhance this further with the semantic search application. This was Supply Chain Inspector in a nutshell. If you'd like to know more about this, please feel free to contact us at any point in time. Thank you for your time. Have a nice day.
Michel, nice overview, I think, of an important tool for to support the selection and identification of suitable spare parts for additive manufacturing. So I'm looking at the chat. There was one question that says, what should be the main scoring and filtering criteria? So maybe we could deal with that question first. And then I have another question about the tool itself.
Yeah, the main scoring and filtering criteria are, of course, two-folded. As I mentioned earlier, you have the supply chain criteria that you're looking into to see whether it's feasible from supply chain point of view. And the second one would be the technical criteria that you look into in order to see whether the part is, from a technical point of view, eligible for additive manufacturing.
So we're talking about printability, let's say.
Exactly.
But also, how do you say, the age, the relative age of the spare part.
Yeah, basically what we can do is build a business case to justify the integration of additive manufacturing in the supply chain, and also do a feasibility study based on some basic technical aspects which are available in most of the companies.
Yeah. So does the tool fully support the development of this business case?
Yeah, definitely.
Yeah. So which means you also need to introduce, let's say, cost data and that's
what we take into consideration.
So it's basically a full service solution.
Yes, yeah, that's what's also in the video is we offer an end-to-end solution for the entire integration of additive manufacturing in the supply chains of all.
Okay, thank you very much. There is a quick question. That says, can you talk more in the microphone? Yes, we'll do that. Right. I think we will continue with the third speaker. And that is Joris van der Zande, who works for Dutch Railways, NS, in the area that it deals with maintenance of trains, right? And he is in charge of the 3D printing program within NS.
Thank you very much, Albert. Yes, when we started 3D printing, I was first working at supply chain operations as a buyer. At that time, I noticed that there were different challenges within the supply chain. The supply chain of NS characteristics is, I have to switch my slides, sorry for that. This one, the supply chain characteristics of NS is mainly based on a few things, especially the vehicle lifetime of trains, of course, is very long, almost more than 30 years. You can imagine then when this happens, when you have a long lifetime, then the risk of obsolescence will be very high. For instance, when you have a coffee machine and you have to operate it for 30 years, yeah, you can imagine that it's hard to get the spare parts available. Besides that, in the rolling stock, each country has its own trains set up. So there will be the trains in Holland, for instance, there's a low volume. You only have a few couches, not like in automotive where you have thousands of cars produced. So with this, you have a low volume production, low standardization, high homologation. Homologation is the approval of the train and the parts. And it's a very supply-driven market. There are a lot of, a few big OEMs and train builders. And they are driving the market. Besides that, especially with the old trains, we have limited documentation. So this is one of the things. Then we have more from technical side, we have a complex railway standardization. One thing is very important, especially when you look at 3D printing, is the flame retardancy. All the plastics within the train should be flame retardant, like in the aerospace, because of the safety. And what these challenges I ran into when I was a buyer, and I think already in 2015, where I was thinking, okay, 3D printing. I saw some movies about it on YouTube. I think this can help with solving some problems. So in 2017, we started pilots. We discussed with engineering, with supply chain. Okay, let's start to select 10 parts and just bring it to a sample and look what the capability is of this production method. And that we did. And then we noticed, okay, we had some complex parts also selected, and we noticed, okay, we should not be an engineer because it's too complex and changing the product, etc. The main value was especially in obsolete items. When we selected some items, and we can also only produce one item. So this was the goal to further run this project. So what we developed a program within NS. Already in the beginning were three main topics which are the strategies within NS. Is to build knowledge, of course. We did this with a lot of communication. I will tell you more about it later. Then partner engagement. Of course, we have our suppliers already. They have IP, so we should involve them, and they have the knowledge about the real systems and the components. So we have to involve them as well if they are still in the market. Because we also ran into obsolete items because the supply wasn't available. Had to print those. Then we developed. I think it was later on. We was working on the AM control center, I call it, but that was we do that with the tool of Dynamics at this moment. Maybe to show you in this figure, show you the goals we set in each year. So we started with 10, and then we scaled it up, and now this year we have the challenge to print more than 250 parts. Okay, we started with the knowledge building, and we did this with a lot of communication, as I already told you. We set the goals, and then we need some ideas. Okay, which part we can print? So we did some communication within the internal newsletters. We made some films to make everybody enthusiastic about 3D printing and have awareness. So we used the AIDA model, which you use to drive the chains. And the first part was to aware, okay, what can we do with 3D printing? We did also some challenges with some outside companies. Now we had ideas came from the shop floor, and that helped a lot. So we did some presentation there and printed, and could directly show people, okay, this is the part, you can directly use it. Besides that, we didn't have all the knowledge, of course, within our company. So that's why we connected Alstom, one of our main suppliers, and they were also working on 3D printing already. So we asked them to train our engineers about 3D printing. So that was what helped a lot, because it's an expert in the rail business, and also they knew a lot about 3D printing. On the picture, that was the first item we printed because we needed for the project. It was not available anymore, so we printed that one as the first AM item within NS. Okay, one of the partners is was of course Alstom, where we started the project in, and also CAF, another train builder. And what we did at a certain moment, we had a questionnaire sent to our suppliers to connect them as well, because we can only make this and scale this with our OEMs and our suppliers. At that time, we had already connection with Dimenex and CastLab. CastLab is a casting company. It's also working with 3D molds to produce their casting parts. So they use 3D printing in indirect way. Dimenex was already introduced, of course, and Niels was also involved to look for the next step. The next step is selecting the items. So we used the tool, and I think we started this 1 year ago. Then we said, okay, we have some ideas from the floor, but how can we scale this, the 3D printing parts? So what we did, we from our systems, we selected around 60,000 parts, and we uploaded those on the platform of Dimenex. And then a lot of I had a lot of ideas like, oh, can we filter on this? Can we filter on that? So they adapted this on their system. They make it custom data points. So we could now, especially from our perspective, our wishes, select parts. So what we do when we, for instance, have contact with a supplier and he likes to make a project of this together with us, so we can select those items based on the supplier, and we can directly see, okay, these are interesting parts. So in the beginning, when we start discussing with suppliers, the question came to me, okay, what is your problem? Which part can we start with? And I didn't know, and now I'm more convenienced with this tool to select the correct parts to start printing. And I think also Niels told you this, is that we want to learn a lot and make this, put this in our system. So this system helps us as well to what we learn to adapt in the selection again. So what you see is we have now from the system an advice to print or starting the process of 2,500 parts. But we know of these parts when we select them and when we really look into detail that there are still parts which are not printable because we are missing data, etc. But it will help from 60,000 to make the selection smaller, to select to get into detail of these parts and getting our goal of 250 parts printed at the end of this year. On this platform is also a workflow which our engineering and purchasing are working together. We did this already before we used this selection method, but now we can more automate this because the workflow starts first started from the IDs from the shop floor, and now we can do this in batches from the selection. Say, okay, for instance, this category we can select connectors, for instance. We say, okay, these connectors are interesting for printing, and we can put them in the workflow to start sampling these and check, let them check by engineer if they are interesting to develop further. Okay, this was my presentation.
Okay, thank you very much, Joost. So this is actually raising a number of questions. I will just go through because we still have a bit of time. The first question is, so is this all same part printing? And are you trying to mimic exactly the part that you need with, let's say, 3D printing? Or are you also contemplating improving the parts at the same time?
We did already with the first part because we ran into the problem because of flame retardancy that it should be less than 100 grams. So what we did, the original was the weight was higher than 100 grams, and to place this in the train, we changed the part, made it lighter. So that's directly.
So definitely.
Yeah, we could test this directly because we can print and then look at it and print it again. It's not.
But this
easy.
could still be, let's say, an unexpected consequence, or is this really part of the business case of
No,
additive
no, because
manufacturing?
what I told before, we looked, and when we did the pilot, we noticed, okay, our main focus on supply chain, to have the same product available again, because that's the biggest challenge. And the other part is more the challenge of our OEMer, because we want to push it. Okay, maybe when we have a problem with the item, it's not functioning, then we can look directly in printing, etc. But in general, okay, the item is working, we want to have this available in a quick way. So that's our focus, and not on engineering, because we are not an engineering company,
Right.
and the OEMs should already do this.
Right. Okay. So a second question is about the homologation costs. I think some of us learned a new word today, but homologation. So why are these so high, and how is this affecting the decision to do additive manufacturing?
Yeah, homologation, because we have a safety product, of course, and train is safety relevant, like in aerospace. And I think the homologation is as well that high because our train, the Dutch train, it's not a high volume train, should be approved. So it's taking a long time, and it's also very expensive. A lot of engineers should be involved. So when we buy a new train, and during the lifetime, when we want to change this one, it's very expensive. So we are now also moving or looking at already when we buy a train to have the possibility to print it. So that's also why we are looking at.
This means that you cannot really change a lot of the components of the train because of this homologation process, and as a result, you would like to be able to replicate parts that you need for quite a long time, far beyond the technical or economic obsolescence of these parts.
And especially then,
without having to go through a new cycle of testing and certification or whatever is required.
Yeah, like for simple parts, it's not a big case, but when you go to safety parts, then this is the case. And when it's really obsolete, okay, and you cannot throw away the system like a coffee machine, but you had to have the system running, and you have only a small part, then it can be interesting to print it and have the homologation cost there.
Yeah. And another question is exactly what you already mentioned. Is this used mainly for cosmetic parts with low risk, or also for critical parts that really make or break the security or safety of the train?
We started, of course, with the simple parts, but we know. I showed you also with our network, we are involved with Mobility Costs additive. Where Deutsche Bahn is also involved, and they already printed some critical parts. We did as well, indirect with our casting company. But then still, it's casting, so you don't change. You change only the tooling in 3D printing. But we're moving on because the business case will be interesting. And when we have an obsolete item, it's critical. Yeah, okay, we have to investigate.
There's another question here. It says, do you have a goal on the number of or percentage parts on stock that you would like to have in a virtual warehouse by it's a very specific question, by 2022? And would the stock of these parts go to zero, or would you keep minimal stock levels and replenish via 3D?
Yeah.
So this is basically, I think they want to know the entire spare part strategy of NS.
Yeah, no, yeah, okay. One, I think what we are facing right now with crisis, and we noticed now the last months that supply chain is
Sensitive.
very sensitive, of course. Yeah. So when we had already a digital supply chain in place, we would not have that problem to get our spare parts from starting already in China, for instance. We don't have a specific goal for digitalization of the spare parts. The goal is now more focusing on learning and get more 3D parts. But at the end, we will change this goal more in a business goal. And have not digitalize, but lower our supply chain, our stock costs. Yeah, because our stock costs are very high. So based on our challenge in the supply chain, we are lucky that it was this high during the crisis because we have the parts available, but we want to lower the.
So there is a clear strategy behind this, but not a specific target of
not yet because we are still in a learning phase. That's why we have a learning goal and a goal to print as much as possible, but we can change it later on to a goal to minimize costs. That's the goal.
Okay, thank you very much. Oh, final question: is NS printing spare parts centrally or decentrally? What are the reasons for this decision?
We have no printers, so we print them with Dymanex, with the print hub. So I can maybe show again to the picture of the partners. Fit and Oceans, for instance, are some printing companies. Oceans is in the Netherlands, so nearby, but Fit is in Germany, in Munich, so further away. But most are, of course, they are in Europe. So
it's a partnership network, basically. And you're not contemplating getting your own print shops or some sort of a shared facility with a bunch of other companies.
According to Niels' phase plan, we did it a little bit different than we started directly with the most difficult parts, the parts in the train. We should start it with tooling. Because tooling, you don't have the homologation process, and we could have some printers available in the shops. But what we did, we directly started with obsolete items. But we are thinking about to have some parts of some printers available in the shops for testing and for the tooling. That will help drive also the awareness and the interest of 3D printing.
Okay, thank you very much. I think we still have a bit of time, so I wanted to go back to Niels briefly, because you kicked this off with sort of the conceptual approach of investigating, let's say, the spare part population and doing this selection process. So if you reflect on this, what is your evaluation of the is this what needs to be done? It's interesting to see that NS is not following your phase plan exactly, right? So could you reflect on that?
Yeah, I think for me, like really a key learning is that probably the filtering and scoring is not the first thing that I would recommend in an organization. You know, like when I did actually this piece of research, for me, it was like, okay, let's directly start with the scoring and filtering. But I think actually it is very important to first get the organization involved and to get some initial idea about what this technology is about, and also to engage the organization, you know. And I actually like a lot the slide that is currently on, and I think that's also something conceptually to understand in general. This is an initiative that now finally leads to a point where the supply chain really gets integrated. So this is something that you cannot, as an organization, do alone. So it's really about building this network and also understand how this network works. Yeah, in general, as a conclusion, I think every organization that deals with spare parts has to be already like in it and has to understand what it means for them.
Okay, thank you. So looking at this picture, you see Dymanex very centrally positioned, right, Michel? So I was wondering, does this also touch the way Dymanex is operating in this sort of field? Are you seeing yourself as a central part in these kinds of networks? And does that also mean that you not only work for NS, but you could also actually work for Alstom or CAF or other parties and provide services to them as well? How do you see this for your company?
Yeah, that's a very good question. And what you see is, and I already mentioned that in the beginning, is that we offer an end-to-end solution, and we basically support the customers as well as provide them with a link to the service providers and giving them the knowledge and the platform and the tools in order to identify the potential, but also to convert that into actual parts being printed and shipped to customers. So we manage the entire project.
Yeah, but I could imagine that Alstom approaches you and says, look, we are producing all these spare parts. Could you help us come up with, let's say, a ranking of additive manufacturing potential of all our spare parts. Is that also something that you would then contemplate?
Yeah, of course. Yeah, as I mentioned, we can do the analysis also on their end from a supply chain point of view and a technical point of view, see what's available and where the potential is, and convert that into a strong business case.
Yeah. Let's see, there was another question in the chat here. Would NS share the parts passports with other mobility partners for generic parts and use parts entered in the arena by other eligible partners? Yeah, so this, I think, it triggered a little bit what I was asking Michel about. Okay, how does this work, right? And is this not more like a sharing arrangement that might develop from this? How do you see that,
Joris? Yeah, maybe to add on what Michel was telling is that what we try to do is that we I think that the world is changing to development and production, and I think you see the production on the left side and development on the right side. And now we ask like France, Alstom, okay, can you develop and produce this? But I think there are two worlds separately. And I think Dynamics will help this in selecting, and also the print-ups available. But we share a lot with them because we're already sitting together with Dynamics and Alstom. We plan to have a discussion with CAF. They are involved in mobility cost additive. Because everybody is working together to solve this problem. But the question here now is, where's the win-win? Because we should, yeah. There will be some changes, but okay, but how will it change? That we don't know. But we're driving, and also CAF and also are doing that, driving the 3D printing, but everybody in his way. So we have to be together to change this. So I have an example here, but maybe I can show it also. This is a part printed by CAF, but an exactly copy of this, not a copy, but the same part was already printed from an old train by Dynamics. So and this is placed already in a new train. So you see already, okay, you have a reference link there. So that will help a lot to learn from each other in this area.
I think we are slowly going to close down. So if there are questions in the chat that we cannot address anymore, we will address them on our website. But still 1 or 2 minutes, I think. So one question is actually, I think, following up on the question I just asked Michel about how does Dynamics see its customers in 5 years? Is that still NS, or are you then working for CAF or Alstom or maybe another party?
Well, I think it would be a combination of both, because the same way that NS would need a part, it could also be that we could support Alstom in requests, because if the volume is low, it's also an interest of the OEM of like CAF or Alstom in this case to have a part printed instead of starting a large production batch where there only is a very limited number of parts required. So there is a win-win situation on both, and that's what we also see is that they are really cooperative in that, looking into the additive manufacturing for the lower quantities.
Yeah, so that should be an interesting development.
I also make a statement in this regards. I think like having a tool such as Dynamics, what is of course also really nice is, as a system user, you now suddenly see, okay, for this OEM, this entire list of spare parts is really relevant for additive manufacturing. And now you suddenly don't go to your OEM and say, hey, maybe we can do something together, or like I have this part, but no, I have those 50 parts and I estimate my supply chain benefit to be like per year, whatever, 100,000 euros. That's a totally different discussion than what you would have when you are not systematically assess your spare part assortment.
Yeah. Okay, thank you very much. I think we have to stop now. There are a few more questions, among others, a question about IP, which is an important question in this context, but I think also perhaps a question that leans itself better for an answer on paper. So we are going to stop here. Thank you very much for listening to this webinar of the Top Sector Logistics. You can listen to this webinar via our website, topsectorlogistiek.nl. We will also address the questions there that we were not able to answer in the webinar itself. Do you want to know more about this topic? contact us via info@topsectorlogistiek.nl or also info@servicelogisticsforum.nl. We will organize more webinars on various topics. Keep watching our website and our social media for the current agenda. Thank you very much for your attention. Stay safe and enjoy your day.